In this video, I will talk about algebraic expansions. But before we tap into algebraic expansions, there are certain things that you should be reminded, and we will do a quick revision on that before we tap into algebraic expansions. When we talk about algebraic expansion, the first keyword that came to your mind should be algebra, right? So algebraic expansion is about algebra, and when we talk about algebra, it's about dealing with the unknown, right? And we use the word variable to represent the unknown, a value that has yet to be determined in a certain situation, variable. And that is the definition of variable, a quantity of undetermined value, and usually is represented by letters A to Z. I'll give you an example. For example, Adam wants to buy a certain number of pens. Do you know how many pens? We do not know. Those are the variable. The variable here are the number of pens. We do not know how many pens are Adam planning to buy. And you can use the letter P to represent the number of pens, variable. Algebraic expressions. When you know about variable, you must know about expressions. Expression is just combine the variable, a letters, combine with numbers, a letters and a number, and an operation sign, the four arithmetic operations, plus, minus, multiply, and divide. So three things, algebraic expressions combine the variable, the letters, the numbers, and also the operations. I give you an example to represent a particular situation. For example, Brenton is 10 years old now. After 3 years, his age will be 10 plus 3, 13, right? Simple calculations. If it's after 8 years from now, that will be 10 plus 8, 18. How about after X years? We do not know how many years, but X, an unknown. Then you have to use 10 plus X to represent the situation after X years. So you have a variable, you have a number, you have an operator. This is an example of algebraic expressions. One more thing. This is an algebraic expressions. As I told you, the letter represent the variable, an unknown, a value that had yet to be determined. And you also have number side by side with the variable, and we call it as coefficients. Coefficients. And you have another number alone without any variable. You call it as constant. Those are the special name we assign to it in algebraic expressions. And as you can see, these are the operator. So in between the operator, you have 1, 2, 3, and we call it as term. So there are 3 terms here, 2x, 4y, and 9. Terms are between the operators, remember. Like terms and unlike terms. When you're dealing with algebraic expressions, there will be like terms where you have the same variable and same power. A, same variable, 1, 1, same power, like terms, x, same variable, power 2, same power, same variable, same power, like terms. When you have like terms, you can combine them. You can simplifying it, remember? Something that you have learned before. And when you're dealing with unlike terms, they are with different variable or different term. For example, you have A and B, different variable, unlike terms. P and D, different variable, unlike terms. C, same variable, but different power. So still unlike terms. When you have unlike terms, you cannot do anything with them. You cannot simplify it. You cannot group them together. Just leave it as it is. Okay? Alright, so now we go into algebraic expansions with the prior knowledge that you have. Algebraic expansions is easy. Let's have a quick look on this. Alright, so start with really something simple. If I ask you to calculate 5 multiplied by 63, don't use calculator. Don't use calculator. Would you able to calculate the answer? Probably you still able to do so, am I right? Is there any easier way to break it? Now this is what I'm thinking. If 5 multiplied by 63, you need to do the vertical working. Why not we change it? We change 63 to probably something easier for us to multiply. Says 60 plus 3. Makes sense, right? 63 is 63 plus 3. When I change it to 60 plus 3, I think it's much easier for us to do the multiplications. Says I will have to do with 5 multiplied by 60, am I right? And what do we have? Right, 300. You have 300. Do we stop here? No. You continue to have 5 multiplied by 3 and you have 15. And you put a plus in between them. So you have 300 adding 15. 315 is the final answer. Right? 63 you can break into 60 plus 3 and you have 5 multiplying with 60 and also 3 respectively. So this is what you can do with the numbers. So if I ask you the same thing, just now this is what we do. Can I do with not numbers but an algebraic expressions 2x plus 3? Oh, so probably we can do the same thing, right? So we can still do the same thing. We have 5 multiplied by 2x. So 5 multiplied by 2, you have 10x. And you can have 5 multiplied by 3, you have 15. So 10x plus 15 is your answer. You can still manage it, right? Okay. So we can do that to numbers. We can do that to algebraic expressions. Here comes another situation. We have 2 brackets with algebraic expressions. Algebraic expressions, algebraic expressions. Hey, what can we do? Now this is something that I want to discuss with you in this video. What can we do when we have a situation like this? You are multiplying 2 algebraic expressions, so we call it as expansions. So we expand it so that it's longer, so we call it expansion. I will show you 2 methods on how to sort out algebraic expansions. The first one, I call it as the grid method. Okay, using grid. Okay, 2x. How many x? 2. So this is how I do. I have x here. I have x here. When I sum up, I have 2x. And I have 3 here. So I can break it into 1, 1, 1. Right? So this is 3. 2x plus 3. X, 1, 1, 1. With the same thing. How do you break this? Simple. You just have to put x and also 1. And we are going to multiplying it. So x, you have x squared. X and x multiplied by x, you have x squared. And then you follow. So x and 1, x and 1, x and 1. So x multiplied by 1, you have x, you have x, you have x. Right, the second row. 1 multiplied by x, 1 multiplied by x. So you have x and x, right? Okay, 1 multiplied by 1, 1 multiplied by 1, 1 multiplied by 1. So we have 1, 1, 1. So this is what we do. 1, 1, 1. And then now you can calculate. How many x squared do I have? 2. So your answer is 2x squared. How many x do you have? 1, 2, 3, 4, 5. So you say 5x. And how many 1? You have 3 here. So this is your final answer. 2x squared plus 5x plus 3, the grid methods. It makes sense, right? But what if you have a situation where you have a lot to write? You see, -1. How are you going to break -1? 6. Are you going to write 1 for 6 times? It's very long, right? Is there any way that we can shorten it? Yup, you can think so. You can think of putting 2x minus 1 like this. You can put 2x here, minus 1 here. 3x and 6. So you can put 3x here, you can put 6 here. Okay, and we do the multiplication. Okay, 3x and 2x. What do you have? You have 6x squared. 3x and -1. What do you have? You have -3x. We do the same thing for the second row. 6 and 2x. We have 12x. 6 and -1. And we have -6. Okay, now you can combine it. Okay, you have 6x squared. 6x squared minus 3x plus 12x minus 3x plus 12x and minus 6. Okay, this is the part where like terms and unlike terms is going to work for you. Is there any like terms? Yup. Here. Minus 3x plus 12x. Can you simplify it? Yeah. So you have the final answer. Minus 3 plus 12 plus 9x minus x. Right? This is the expansion. This is how you expand it. Alright, so these are the grid method. I hope you understand this. I show you another method where it's called the cross method. The cross methods. No, not the cross method. You can call it as the crab crawl. I like to call it as rainbow method. Okay, some call it crab crawl. I like to call it as rainbow method. So this is what we do. You have the first term, 2x multiplied by 3x, 6x squared. 2x multiplied by 2, so you have plus 4x. 5 multiplied by 3x, you have 15x. And 5 multiplied by 2, you have 10. Observe, you have like terms here. So you have 6x squared plus 19x plus 10. This is how you expand it. Definitely this is easier. You don't have to draw the grid. This is the crab crawl, or you can call it rainbow methods. We try one more. I give you one more understanding. Eh? Okay, the first one, multiply this one. You have, what do you have? Right, negative 6x squared, followed by negative 2x and negative 1. So be careful on that. You have plus 2x, right? Oh, I'm sorry. And then you follow by these two. You have 9x, and the last one you have minus 3. Okay, we're simplifying the like terms. Here we go. So the final answer, minus 6x squared plus 11x minus 3. This is the final answer. So algebraic expansion is about the product of multiplications of one or more than two, or one or two expressions in brackets. So when you have ax plus b multiplied by cx plus d, this is what you should have. So I have shown you two methods, the grid method and the crab crawl / rainbow methods. Thank you.